I'm now going to explain how we can truncate the outer loop of the Bellman-Ford algorithm. In the previous video, I said we might have to go all the way to the total number of vertices. The outer loop might have to iterate that many times. But it doesn't have to iterate if we have already achieved the optimal solution. And we can check on that by using a Boolean variable which I'll call changed. And the outer loop will only iterate if a change has occurred in the previous iteration of the inner loop. So in order to get it to iterate once, we have to initialize changed as true. And then when we start the outer loop, we initialize changed to be false. And then during the inner loop, we may or may not reassign the value true to changed. Now, the inner loop iterates n times, once for each edge. And for a particular edge, let's say EI, which goes from XI to YI, we ask ourselves the question, if we take the best path from so far from S to XI, and we adjoin an additional arc from XI to YI, will we get something that is cheaper than the best known arc from S to YI? In this case, 9 plus 5 is less than 14. So in this case, the value of changed would be set to be true. Of course, it could be set to be true several times, but that doesn't matter because it'll be true if there's a change at least once. So this is the relaxation step. If the cost of this path plus that arc is less than the cost of that path, then we update the cost of YI and we get a new path to YI, and the back pointer of that new path from YI goes to XI. We also set changed to be true. Now we iterate this over and over again until, this is the end of the inner loop, until changed is no longer true or we reach n. Now, if we reach n and changed is still true, that's impossible if there is no negative cycle. So therefore, if changed is still true when we exit, we know that there is a negative cycle in the graph. Otherwise, the values of cost, the array cost and the array back will be